A pleasant greetings to all. In this video, I am going to explain one problem in shunt generator. So what is generator? Generator is a machine which converts mechanical energy into electrical energy. Here the problem is the shunt generator delivers 195 ampere at terminal potential difference of 250 volt. The armature resistance and shunt field resistance 0.02 ohm and 50 ohm respectively. The iron and frictional losses equal to 950 watt. Find the EMF generator, copper losses, output of the prime mover, commercial, mechanical and electrical efficiencies. Okay, so first of all, I am going to draw the diagram of shunt generator. What is shunt generator? The shunt field is in parallel with armature, that is known as shunt generator. Okay, see, this is a shunt field that is connected in parallel with the armature. Here, this is the symbol for the generator. Okay, then finally it is given to the load, because in a generator mechanical input and electrical output. So this is the terminal potential V, and here this is the current IL. The generated current is armature current IA. So inside we are having RA and generated voltage EG. See, RSH is the shunt field resistance. The current flowing through is ISH. What are the data given? V is given 1, that is 250 volt. And what is the current given? Shunt generator delivers 195 ampere. This is the load current. And next, what are the values given? Shunt field resistance RSH is given 50 ohm and RA also given 0.02 ohm. And what are the mechanical losses? Iron and frictional losses is otherwise known as mechanical losses. So what are the mechanical losses? What is the value given? 950 watt. Okay, this is the mechanical loss given. And what is the first question asked? That is EMF generated. EMF generated is generated EMF in the armature. So EG, that is EMF generated. Okay, see here. First of all, we are going to find out the EMF generated. For this, I am going to apply the Kirchhoff's voltage law in this closed loop. Okay, in a Kirchhoff's voltage law, what is the equation? EG, that is the rise in potential, so EG, and here RA, the current is flowing, so positive and negative here. So what is the voltage drop? That is IA into RA, EG minus IA RA minus V is equal to 0. So what is the value EG now? EG equal to V plus IA into RA. So that is the equation. What is the V given? V is 250 volt, that is V given. What about the value IA? The IA value is, so here I am going to find out IA. So how to find out IA? So IA equal to ISH plus IL. Okay. So what is ISH? ISH equal to V divided by RSH plus IL. V divided by RSH is V is equal to 250. What is RSH? 50 plus IL is 195 ampere. Cancel 5. So what is the answer? 200 ampere. So this is the value of IA. Now V is equal to 250, 200 ampere into what about RA? RA equal to 0.02. Now you have to multiply this. We get the value 4. Okay, 254 volt. So this is the value for EG. So the first answer is over. EMF generated is 250 volt. Okay, next I am going to copper losses. So what is copper losses? Copper losses, two different types of copper losses occur. So whatever the field winding, wherever the field winding is there, we are having losses. Field winding is made up of copper. Copper consists of very small amount of resistance. Here, shunt field consists of copper. Armature conductors also consist of copper. So two losses are there. One is field copper loss, that is ISH square into RSH. Then armature copper loss, so IA square into RA. Already we got the answer for our ISH, phi square into the value equal to, what is the value? 50 ohm, 50. And plus, what is IA square? IA is equal to 200. So, 200 square into 0.02. So, what about phi square into 50? That is 25 into 50, 1250 plus 200 square into this one is 400 into 2, that is 800. So, yes, you have to add both 5, then 2050 watt. So, copper losses is known. Now, copper losses is 2050 watt. And next, what is the question? Output of the prime mover. So, output of the prime mover. So, output of the prime mover means the overall mechanical overall output of the prime mover. Okay. So electrical output means actual, what first of all you have to find out useful output power. What is the useful output power? Useful output is output obtained in the terminal point, that is the load point. Output obtained in the load. In the load, what is the voltage? 250 volt, and what is the current? Current is 195. So multiply both, we will get the useful output. Now I have to multiply 250 into 195, that is equal to 48750. 48750. So that is the useful output. Okay. Then output of the electrical output. Next we have to find out the electrical output. So what is the electrical output? Here this output 48750, that is added with the copper losses. So this is the electrical losses. So that may be a electrical output. So plus 2050. Okay, 50,800. 800 watt. Okay, that is the electrical output. So next I am going to find out the next output, that is the prime mover. So output of the prime mover means the frictional losses also included. So mechanical losses is included. So that is the output of the prime mover. So what is the output of the prime mover? The output of the prime mover, that is equal to 50,800 plus the losses is given. Frictional losses 950. Okay, this is added with 950, so that is equal to 51,750. 51,750 watt. So this is the output of the prime mover. Okay, that's all. Next I am going to find out the D portion, that is the commercial efficiency, that is the overall efficiency. And next mechanical efficiency, eta m. And next, what is the electrical efficiency? So first of all, in any generator, first the prime mover is there. In a prime mover, first we get the mechanical output. So mechanical output from the prime mover. So in the armature, the mechanical power equal to electrical power is generated. Electrical power is generated. Then in the armature, electrical power is generated. Afterwards, this is given to the load. Okay, in the load portion, useful power is our final output. Useful power is generated. Okay, useful power is generated. So here, see here, in this mechanical power, VIL, useful power is what? V into IL. That is the useful power. Electrical power means what? V into IL plus the losses, that is copper losses, the electrical losses. And next see here V into IL plus copper losses plus the stray losses also there, stray losses. Then we get these copper losses only. Final output power we get VIL only. So first, what is the useful power? What is the efficiency? What is the overall efficiency? Overall efficiency is what? Well, useful power. Okay, useful power. Then input to the prime word. So here VIL plus copper loss, output obtained from the primer, copper loss plus stray loss. Okay, so that is a total power input and useful power output. So these are the total power input or mechanical power, total power input. Okay, useful power is what? Useful power is 48750. What is the total power or mechanical power? 51750. Now I have to divide this. So 48750 divided by 51750, that is equal to 94.2 percentage. Here this power is very much less, that is the overall power. And next I am going to find out the mechanical power. So what is the mechanical power? Eta m. Eta m is the mechanical power. So what is the output? Output power is the electrical power output and mechanical power input. So that is the mechanical efficiency. So electrical power output. So electrical power output means what? VIL plus copper losses. So this is the electrical power output. Okay, what is the input? Input means VIL plus copper loss plus stray loss. Okay, stray loss. So this is the input mechanical power. So VIL plus copper loss, the value is what? The value is equal to 48, value equal to what? That is 48,750 plus 2050, that is equal to 5800 divided by what is the overall mechanical power input? 51,750. So that is the answer, 5800 divided by 51,750. So what is the answer? That is 98.16. That is the mechanical power, mechanical efficiency, 98.16. And next I am going to find out one, that is the electrical efficiency. So electrical efficiency means what? Useful output power divided by electrical input. Useful output power. Useful output. So useful output divided by electrical input. Electrical input. So this is V into IL. This is VIL plus copper loss. That's all. Copper loss. Okay. Useful output, that is the first one, 48,750 divided by what is the value? 48,750 plus 2050. So that is 5800. 5800. So now I am going to find out the value into 48,750. So the answer may be 95.96. So that is the answer, 95.96 percentage efficiency. So which efficiency is more? That is the mechanical efficiency is more, then electrical efficiency, then overall efficiency. So this is in the decrease in order. That's all. These are about the efficiency in the shunt generator. In this way we can find out the efficiency as well as the overall output for any type of generator. Thank you. Have a nice day.